Today we will be reviewing some circular motion example problems. There are three formulas we could potentially use with these practice problems. Centripetal force is equal to mass times velocity squared divided by the radius. Centripetal acceleration is equal to velocity squared divided by the radius. And tangential velocity is equal to 2 pi times the radius divided by the period. Number 1. A cyclist turns a corner with a radius of 50 meters at a speed of 10 meters per second. What is the cyclist's acceleration? Well, here we know from the problem, we have our radius of 50. We have a speed or a velocity of 10 meters per second, and we're looking for acceleration. And in this case, because he's going around in a circle, it is centripetal acceleration. Our formula is centripetal acceleration is equal to velocity squared divided by the radius. So here we'll fill in our numbers. Instead of v, we'll put 10, and make sure you include the squared, divided by the 50 for the radius. 10 squared divided by 50 is 2 meters per second squared. Number 2. A 60-kilogram Gila monster on a merry-go-round is traveling in a circle with a radius of 3 meters at a speed of 2 meters per second. What acceleration does the monster experience? So here again we have a mass of 60 kilograms. We have a radius of our circle of 3 meters and a velocity of 2 meters per second. They're going around in a circle, so we're looking for centripetal acceleration. That is v squared over r. Our v number was 2, so we'll have 2 squared divided by our radius number of 3. Now we don't really have a place in our formula for the 60 kilograms, so that's extra information in the problem. You just leave it in your left-hand lineup and don't worry about it. To solve, the 2 squared divided by 3 gives you 1.33 meters per second squared. Number 3. A 515 kilogram roller coaster car is at the bottom of a loop with a radius of 9.8 meters. If the acceleration at the bottom of the loop is 20 meters per second squared, what is the speed of the roller coaster car? Here we know the mass of the roller coaster car, that's 515. We know the radius of the loop, 9.8 meters. And we know the centripetal acceleration is 20 meters per second squared. Here we're going to still use our centripetal acceleration formula. Centripetal acceleration equals velocity squared divided by r. We know our acceleration, that's 20, and we're going to set it equal to velocity squared divided by our radius number of 9.8. And again, we don't happen to need the mass. That's okay. When we're solving for velocity, we need to multiply both sides by 9.8. 20 times 9.8 is 196. That's v squared. We don't want v squared, though we want v. So in order to get rid of the squared, we're going to take the square root on both sides. The square root of 196 is 14 meters per second. Number 4. A 14,000 Newton car is traveling at 25 meters per second, and it rounds a corner accelerating towards the center of the curve at 3 meters per second per second. find the following. So in the first question, we're going to try to find the radius of the curve. Let's start by writing down what we know. We know the force of gravity, or the weight of the car, is 14,000 newtons. We know its velocity is 25 meters per second. And we know its centripetal acceleration is 3 meters per second squared. In order to find the radius of the curve, we can use the formula for centripetal acceleration because we have acceleration and velocity and are looking for radius. Instead of centripetal acceleration, let's put in 3. Instead of v, 25. Don't forget to add your squared. And below that, we're going to leave our r. The first thing we need to do is multiply both sides by r. This leaves us with 3r equals 25 squared. Next up, we need to divide both sides by 3. This leaves us with r equals 25 squared over 3. Put that into the calculator, and you get 208 meters. Part B asks you to solve for the time it takes for the car to make an entire circle if it's accelerating at this rate. Your formula for tangential velocity is 2 pi times the radius divided by the period. The period is the amount of time it takes for it to go around the circle. So, let's put some numbers in. We know the velocity is 25. We know 2, and we're just going to leave pi written as pi. It'll go straight in your calculator like that. Times our new radius of 208 divided by period, or capital T. The first thing we need to do is multiply both sides by t. And we will get 25t is equal to 2 pi 208. Next, we'll divide both sides by 25. This will leave us with t, or period, is equal to 2 pi 208 divided by 25. You'll put this into your calculator and make sure you are using the pi symbol button on your calculator. When you put all this in, you should get 52 seconds. Note, if you're working from the TI-36 calculator, the pi button is the 4th button down on the right, and it has a pi, an E, and an I in it. You just push that, and it puts the value for pi into your calculator for you. And lastly, number 5. Timmy the angry teen twirls a dead rat with a mass of 2 kilograms attached to a rusty chain with a length of 1 meter in a horizontal circle. It takes 0.75 seconds for the rat to make 1 revolution, goes around once. Letter A, calculate the tangential speed of the rat. Let's start by writing down what we know from the problem. We know the rat has a mass of 2 kilograms. The length of the chain was 1 meter, that's our radius. And it takes a time of 0.75 seconds. So, when we're calculating the tangential speed, our formula is v sub t is equal to 2 pi r divided by the period. So we'll put our numbers in, and that gives us 2 pi 1 divided by 0.75. When you put that in the calculator, you get we get 8.37 meters per second. Part B, calculate the centripetal acceleration of the rat. So here to find the centripetal acceleration, we're going to take our velocity number that we just found, square it, and divide it by the radius. So 8.4 or 8.37 squared divided by 1. This will give you 70.06 meters per second squared. Here's a bonus problem for you. A 0.5 kilogram ball moves in a circle that is 0.4 meters in radius at a speed of 4 meters per second. Calculate its centripetal force. So in this case, we know the mass of 0.5 kilograms, we know the radius of 0.4 meters, and we know the velocity of 4 meters per second. And we're looking for centripetal force. So here's our formula. Centripetal force is equal to mass times velocity squared divided by the radius. So when we put our numbers in, we're left with 0.5 times 4 squared divided by 0.4. When you put that in your calculator, your answer is 20 newtons. All right, guys, those are our 3 formulas. Good luck with your practice problems.